physiology as a whole. With physiology, it is important to note that physiology is the study between how the body's structures function with one another. And so, it's different from anatomy, because anatomy is what the structures are, where they are, and their neighbors saying hello. And so, for physiology, let's talk about how structures work together. So, for example, red bone marrow. Red bone marrow is responsible for making red blood cells. These red blood cells need iron to make hemoglobin. And then these red blood cells can carry oxygen and carbon dioxide as the main components, and it travels around the body. And so you have the heart, which is responsible for pumping the blood. And so you have it go in through the heart. And then you have your ventricles, you have your atrium, you have your valves, and then it goes over to your lungs to get fresh oxygen, comes back, and then it goes up through, and then down, and then blood is sent throughout your body. And so this oxygen-rich blood then powers the rest of your organs, gives it fresh oxygen and everything else that the blood carries, which can be cholesterol, it can be carbohydrates, lipids, it can be proteins, calcium, sodium, basically everything the body needs. And so when you're having the blood pump, you're having it pump down through the inferior vena cava, and you're going to have arterial. Arterial is when the blood goes through to the body, and then venous is the return of the deoxygenated blood back to the heart and then back to the lungs in order to get it reoxygenated and then continue with the cycle. And all this is controlled by multiple factors, and one such factor is the electrical signaling of the heart. And so the heart has multiple nodes. You have the sinoatrial node, you have the atrial node, and then you have Purkinje fibers. And so first the sinoatrial node, atrioventricular node, Purkinje fibers, and the Purkinje fibers are at the apex of the heart, which is actually down at C5, and so mid-clavicular, and so it's going to pump, it's going to be the pushing force, and it needs enough force to propel the blood throughout the body, and so it squeezes as hard as it can from the signal of the Purkinje fibers, and that causes the opening of the aortic valve, and the valves that go together are the pulmonic, the aortic, those are the top two, and then you have the bottom two, which are the mitral and the tricuspid. And so when your heart contracts and squeezes, then it's opening up the pulmonary and the aortic, and the blood goes through the aortic valve, and it goes through the aorta, and then descends again through the inferior vena cava. And so the way that the heart works is that it's also a muscle, and a muscle needs potassium in order to pump, in order to be strong, in order to be healthy enough and buff enough to pump that blood. And so the reason why you have problems with low potassium can cause arrhythmia, and it can cause death because it's not squeezing enough, it's not getting enough blood, which means you're not getting enough oxygen to the rest of your organs. And when you're not getting enough oxygen to the rest of your organs, that's called ischemia. ischemia is lack of oxygen to an organ, and it results in the shutdown of the organ and death, necrosis of the tissue. And so that is why a lack of potassium can be fatal. And it just shows that there are so many factors that go into having a healthy body. And so next you have the heart pumping. And so you have S1 and S2. Those are the two different heart sounds you hear. And so S1, it's first, right? And so you're gonna have tricuspid mitral. S2, you're going to have pulmonic aortic. Closes first, closes second. And so you're gonna have that heart sound, that love dub. Close, 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 close. Doom, 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 doom. And that is just the valves closing. And so we also have a major factor with the hormones and also the bones, the skin layers. But for now, we're just going to talk about the bones. And so your bones actually don't start out as bones when you're growing as a child. They actually grow out, I believe, as cartilage. And that cartilage eventually turns into bone. And the bone is created through osteoblasts. The osteoblasts take calcium and build up the bone. And then the osteoclasts destroy the bone and bring calcium back into your bloodstream. And so when you have an imbalance of these two factors, then you get what we all know, osteoporosis. It's brittle bone, and the reason being is because you have too much bone breakdown versus bone building, which means osteoclast activity is greater than osteoblast activity. And this actually occurs starting at around age 25. It's when your bone building peaks. It peaks very early on in life. And so it's actually, that's why it's a big problem in older adults, is because it starts early and then continues to go downhill. And so the older you live, I mean, you're just gonna have more problems, obviously, but that's one of them. And so that bone breakdown also causes more calcium to be in the bloodstream, which can also be bad because too much of anything is a bad thing, right? And so there's also certain nutrients that stay in the blood or don't, right? You have fat soluble and water soluble. And so an example of fat soluble is, I believe, vitamin A, D, E, and K. Actually, I'm not too sure about that. It's A, D, E, and K go together, and then B, like on its own, basically, right? I believe it's fat soluble though. B, I think, is water soluble. Never mind, ignore that. I'm gonna have to review that later. But so you have osteoarthritis, which is the wear and tear of the joints, because as you get older, the more you're gonna be moving your joints, and the more wear and tear you're gonna have on the collagen and the fluid. So on your knees, you have synovial fluid, and so you're just gonna have continual wear and tear, which eventually leads to bone-on-bone friction, which causes the pain and osteoarthritis. And so it's very bad because it's the bone rubbing against each other, and it causes immense pain. But it looks like that's all the time we have for class today, so I'll pick it up another time. But yeah, thank you so much for stopping